parasite. As you can see here, we have IPv6 in today's network. And again, here what we have is, obviously here it's saying more than 50% of PCs support dual stack. So most of them use auto configurations such as Slack to get the IP address. Again, we mentioned the Vista and 7 and so forth. And here it's saying, IPv6 is preferred protocol by default. Now keep in mind, as I mentioned earlier, IPv4 is probably going to be the preferred one for now still, because it still works. And why upgrade everything when things still work? Now, as things, of course, happen more and more in the attacks, then obviously we're going to be moving towards a default of IPv6. But anyhow, it's definitely incorporated, and we're doing the dual thing right now. Now, steps to make an attack: basically set up attacker's IP to act as the RE sender. Now, prepare the DHCP-v6 server on the attacker's PC. As DNS servers provide attackers' addresses, modify the behavior of DNS server to return an A or a quadruple A record. And again, the A record is the IPv4, and the AA record is the IPv6 record, which basically points it's a DNS pointer from IP name to IP scenario. All right, and then rename it basically from whatever to your attacker's address, and then transparent proxy service allows the attacker to modify the content of the web pages possibly, and so forth. Okay, we have extension headers. Each header should not appear more than once, with the exception of destination. We have options header. This is going to be a hop-by-hop extension header. Should only also appear once. We have hop-by-hop extension header should also be the first header in the list, because it examines by every node along the path. We have destination options header, which should appear at the most twice, before routing header and before the upper layer headers. We have destination options header should also be the last header in the list, if it is used at all. We have header manipulation, such as crafted packets and so forth, large chain of extension headers, separate payload into second fragments, and we can also consume resources, which also provide possibly invalid extension headers, which allows us to do things like denial service type of attacks, and so forth. Now, let's see if I actually have anything else to add on to that, which I don't think I do, outside of what we have right here. So, so you can see here, right, the IPv6 header, routing header, authentication header, and so forth. So let's look at the routing header specifically. So here, the routing header is used by an IPv6 source to list one or more intermediate nodes to be visited, in quotes, right, on the way to the packet's destination. This function is very similar to IPv4's loose source and record route option. Awesome. So if segments left is 0, the node must ignore the routing header and proceed to process the next header in the packet, whose type is identified by the next header field in the routing header. If segments left is non-zero, the node must discard the packet and then send the ICMP parameter problem, code 0, which in this case messages to the packet source address, pointing to the unrecognized routing type. If, however, after processing a routing header of a received packet, an intermediate node determines that the packet to be forwarded onto the link, whose link MTU is less than the size of the packet, the node must discard the packet and then send the ICMP packet to big message to the packet's source address. Awesome. How about that? We have different types of routing headers. So routing header type 0, also going to be referred to as RH0, is the evil mechanism. And again, some of these things too might be coming right into exam info, by the way, and so forth as well. Which real quickly, since I mentioned the exam, you do have hopefully the CPTC prep guide, which will be great for studying for your exam. It's an old project funded by the DARPA, which is your Defense Advanced Research Project Agency. Awesome, right? This type is generally going to be unused, and we have type 2, which is used by IPv6 and only understood by IPv6 compliant stacks. And again, this is going to be one of those things, right? To allow specific filtering, type 0 routing headers, and so forth. right? And these are going to be basically your mobile IPv6, right? So that's what your type 2 is, for your mobility support in IPv6, MIP. Okay. We also have the ability to do layer 3 and 4 spoofing and such. We basically use tools like SCAPI6 for this, right? We have the IPv6 Bogon Martian filtering, called Martian filtering, which basically will filter traffic from unallocated space and filter routing advertisements of bogus prefixes. It also permits legitimate global unicast addresses, and generally here we have a hierarchical addressing of your ingress and egress filtering. We have inbound infrastructure ACLs, so IACLs, access control list right there, right, that deny packets sent to an infrastructure IPv6 address. We have IPv6 receive all, as in receive your ACL, your RACLs on Cisco devices, and we also have unicast RPF checks, which also we find through the RC28. We have other things that can go on, such as transmission mechanism threats. We have dual stacks, preferred, right? So you're only as strong as the weakest of the two stacks. So running dual stack can give you at least twice the number of vulnerabilities. We have manual tunnels, which are also preferred. There's a filter and tunnel source destination to use IPsec. If spoofing returns traffic, it's not going to be sent. We have dynamic tunnels. So 6-to-4 relay routers are open relays. And this is basically we're saying from V6 to V4. We also have what's called ISA-TAP. How about that? ASA-TAP. And that's your intra-site automatic tunnel addressing protocol. And it's basically an IPv6 transition mechanism, that's what we're talking about, meant to transmit IPv6 packets between dual stack nodes on top of an IP4 network. So we have potential man-in-the-middle attacks there. The attackers can spoof the source destination of your IPv4-6 addresses. We have protocol translations, which generally are not going to be recommended. We have deny packets for transition techniques not in use, such as deny IPv4 protocol 41 forwarding, unless it is exactly what is intended, unless using 6-to-4 tunneling, and deny UDP port 3544 forwarding, unless you're using the Teredo-based tunneling, which again kind of goes into what I was mentioning earlier, where if we have IPv6 going to IPv4, it would then use UDP packets and so forth, and it was actually brought through the Teredo-based tunneling is what this is also referred to as. So pretty cool stuff overall. Other things would be IPv6 firewalls, right? So don't just use your IPv4 firewalls for IPv6 rules, obviously. That would hopefully make a lot of sense. And then we have don't just blindly allow IPsec or IPv4 protocol 41 through the firewall. Separate firewall policies for IPv6, obviously. Okay. Look for vendors that support extension headers, fragmentation, your PMTUD, which I'm actually going to have to look that one up real quick. PMTUD, okay. PMTUD is your path MTU discovery. There it is. That P and the D there for the MTU kind of got me confused there for a minute. So it's the path MTU discovery, which is a standardized technique in computer networking to determine the maximum transmission unit size for the network path between two internet protocol hosts, usually with the goal of avoiding IP fragmentation. There it is. Other things that we have going on is, let's see, for granular filtering and so forth. Okay. So we also have some hosts that have multiple IPv6 addresses. So this could also make firewall troubleshooting very tricky. And we have layer 2 transparent firewalls, which are more difficult to implement with IPv6 because of the required ICMP v6 stuff. Our network discovery, solicitation type stuff, your NUD, which is your neighbor unreachability detection, all right, and your AS and your RA that we mentioned, RA and RS messages and so forth that we also type. So again, there's so many cool things, right, new things that come on when we're talking about new things like IPv6 and so forth. But anyhow, so here, making existing tools work. It's one of the challenges with assessing IPv6-enabled systems, making existing security tools work with IPv6 address formats, especially local scope ID. So for instance, we have NIC2 Web Scanner, which is an excellent tool for web assessments, but it does not have direct support for IPv6 addresses. So while we can add an entry to the etc host file for IPv6 addresses, we want to scan and pass on the NIC2. However, NIC2 is unable to process the scope ID suffix. So the solution is here is that many other tools' compatibility issues is to use TCP/v4 to TCP/v6 proxy service. And by far, this is the easiest tool which, for that is a tool called SOCAT, which is also available with packaged most Linux and BSD distributions. It basically does a relay to the local port 8080 on the remote port 80 for a local link IPv6 address. And then we use the command, like you see here with our SOCAT TCP listen 8080, we use address fork TCP6 : blah, 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 and then pop it in with our NIC2. So once SOCAT is running, we can then launch NIC2, and we basically do it against port 8080 on our local host. So in this case, it would be 127.0.0.1, right? And then basically here we put in our NIC2 with the host 127.0.0.1 with the port of 8080, right? Pretty cool. And this basically port forwarding techniques that use for many other tools and protocols, which is great fallback when the tool of choice does not support IPv6 natively. So again, pretty cool stuff overall when it comes down to it. Obviously, though, there are more and more tools out there that are getting the job done on working specifically with IPv6. So overall, pretty cool. Okay, and this then takes us through the module of IPv6. Hopefully it was somewhat okay to understand, maybe not easy to understand, but somewhat okay to understand. Obviously there's a whole lot more to it, and I would recommend that you check out other sources too to get a better feel, maybe better simplified version of explanation and whatnot on some of this too. Because I know we went through this fairly quickly, and I gave you a lot of information that wasn't on the slide as well. So we talked about it that IPv6 had all the security issues that IPv4 has, but also has distributed denial service, address spoofing, right, fragmentation, and so forth. Right. Some attacks are also more difficult to perform, such as scanning that we mentioned, but we could use, of course, the THC tools for that, and of course, it has better network filtration availability. Now, some are easy to perform. Right. We mentioned RA. We mentioned DHCPv6. And spoofing and so forth. We mentioned ICMPv6, which tends to be more complex and so forth. But obviously, we gave you hopefully some additional resources that you could check out on that and so forth on that end, right? Header recorder flow, lack of knowledge on how to secure the network is probably going to be a big thing out there too, is that we still have a lot of administrators, once they are going into IPv6, they maybe don't know exactly how to secure it, because it tends to sound like, hey, it's secure off the bat, which it is to a point, right? Because it has that the IPsec within it, and so forth. And using it with the right technology and the right, implementation of servers and so forth, we're able to harness the best functions and the best features of IPv6, such as I mentioned, like direct access, as I was mentioning. Which basically allows us to remotely connect into the server without VPN in first, right? So Juniper VPN goes away, and whatever else that you're using goes away because we're doing direct connects. Now, obviously, you have to have, as I mentioned, certain versions of the software to make this happen. But needless to say, we have that capability. We have those features now, and companies are starting to slowly utilize those and so forth, right? But anyhow, so as we get rid of your VPNs and your VPN concentrators, whatever else, we're slowly going into that. Again, we're going to see this more and more in IPv6, obviously. Right, transition techniques are also a new way to perform attack. So avoiding firewalls, probes, intrusion detection, and intrusion prevention systems, things like that. Right, and address behind NATs can also be accessible from anywhere. Remember that with IPv6 natively, it's not supporting NAT anymore. Right, so NAT goes away, ARP goes away, and things like that.